then you have a bomb. Well, we have made the bomb, have we? Well, don't even think about it. Let's not think about destruction. Let's think about construction now. How can we use nuclear energy in a constructive way, in a peaceful way? Well, it is being used in a peaceful way in many parts of the world. The construction of a nuclear reactor. So a nuclear reactor is a device in which chain reaction is allowed to proceed at a controlled manner so that we can harness the energy of fission and use it to produce electricity. Well, there are snacks in it, there are merits in it, and those kind of things are debated these days. If you follow the politics of energy, I'm sure you understand a lot of it. To maintain a sustained, controlled reaction for every 2 or 3 neutrons that release per fission, one must be allowed to proceed to do further fission. Not more, not less. If it is more, it becomes supercritical. If it is less, it becomes subcritical. So, if this is a nucleus of uranium that undergoes fission, if there are 2 neutrons produced, one must be taken away, removed, and only one must be allowed to proceed further. And again here, fission, free neutrons, one must be removed, and only one should be allowed to proceed. That means there must be some kind of an effective control system to control the rate of fission. The rate of fission cannot accelerate. It cannot decelerate. It has to be maintained at a constant rate. If the ratio is less than 1, well, the ratio of neutrons available for further fission is less than 1, the reaction will die down. If it is more than 1, it becomes a bomb. If you make a reactor and it becomes a bomb, well, then we failed in our purpose. Nuclear reactions can be controlled by using neutron-absorbing materials. Now, boron is a good example of neutron-absorbing material. So, in a nuclear reactor, you have control rods which are made of boron, which will absorb extra neutrons, and only 1 neutron per fission is allowed to produce further fission. So a nuclear reactor is a device in which chain reaction is initiated, controlled, and sustained at a steady rate. Now, here is a sequence of what happens there. If you have 1 uranium-235 undergoing fission by absorbing a slow neutron, it produces barium, krypton, and say 3 neutrons. Now, out of the 3, there is a material called moderator. Now, we will talk about that as we go on. A reactor contains a material called moderator. Moderator, the purpose of the moderator is to slow down the neutrons, because fission is produced by the absorption of slow neutrons by the uranium nuclei. So, these neutrons, when they hit against the molecules or nuclei of the atoms of this moderator, they slow down. And now, a number of these need to be removed by what are called control rods. So control rods are used to remove the extra neutrons, and only the fission is allowed to proceed at a controlled rate. All right. What are the major components of a nuclear reactor? Now, of course, fuel. What is the fuel used in a nuclear reactor? Now, the fuel used in a nuclear reactor is pellets of uranium oxide, UO2. And they are arranged in tubes to form the fuel rods. So nucleum oxide in steel rods form what are called fuel rods. The rods are arranged into fuel assemblies in the reaction core at the center. I'll show you a diagram as we go on. Now, the second important part of a reactor is the moderator. And I mentioned what a moderator is in about a couple of minutes ago. A moderator is a material that is used to slow down neutrons. If neutrons produced in a fission are not slowed down, they will simply escape from the body of the reactor. They need to be slowed down, and the slowing down is done by repeated collision of these neutrons with the nuclei of some materials. Well, heavy water is a good example of a moderator. Some reactors use graphite. The carbon nuclei are very effective in slowing down neutrons. So graphite is a good moderator, and heavy water is another good moderator. That means heavy water is actually an important ingredient in making reactors. And reactor is an important ingredient in producing actually fissionable material. And that's the reason why during the Second World War, Germany was feverishly working with reactors. And they needed a lot of heavy water. What is heavy water? Well, normal water is H2O. Heavy water, instead of the normal hydrogen, you have the isotope of hydrogen, which is deuterium. That is one proton and one neutron. That is deuterium. So the water made of a combination of deuterium and oxygen is heavy water. And the heavy water is very effective in slowing down neutrons. Now, Hitler was constructing a heavy water plant, and one of the aims of the Allied troop was to go and destroy it. Actually, there is a movie which shows clearly the plan and how they executed the destruction of the heavy water plant that Hitler was building somewhere in Europe. So, moderator is the electron to slow down neutrons. Now, control rods, we again talked about it. Control rods are controlling devices, materials that can absorb neutrons so that the chain reaction can be allowed to proceed at a controlled rate. And most commonly used material is cadmium, hafnium, or boron. They are all effective nuclear absorbers. Another important part of a nuclear reactor is coolant. You know that nuclear reactions, the nuclear fission, will generate large amount of energy. And that energy, most of it will appear in the form of heat. If that extra heat is not removed, the nuclear reactor will melt down. And a meltdown will cause almost like the explosion of an atom bomb. A lot of radioactive materials will be released. So a meltdown in a nuclear reactor cannot happen. You need to effectively remove the heat produced during fission. So these are the important parts of a nuclear reactor. And you can see I've illustrated that in here. Now, these are the fuel rods. This is the complete reactor body. And this is the core of the reactor. They are the fuel rods, uranium oxide. And it is inside a steel chamber. And you have control rods. And the moderator is actually water, heavy water. Now, coolant. Water also is used as the coolant. That means this water being circulated will remove heat and give it out to the water that is circulating here. That means this heat from the core of the reactor can be extracted by this water, which when circulated through this tube will heat up the water in here. which will produce steam, and the steam will then drive the turbines, which will then produce electricity. And this water can be recycled and can be pumped back. Well, that is in a sense what a reactor is. So heat is produced in a nuclear reactor when neutrons strike uranium atoms, causing them to fission in a continuous controlled chain reaction. Neutron absorbers are placed among the fuel rods for achieving that controlling process. When the control rods are pulled out, you can actually shut down the reactor by pulling out the control rods. You can start the reactor by inserting the control rods. Now, when they are inserted into the core, more neutrons are absorbed and the chain reaction, well, the chain reaction can be stopped or allowed to control in a controlled manner. Most commercial reactors use ordinary water to remove the heat. Now, if you want the two jobs to be done by water, that is the job of a moderator and that of a coolant, then you have to use heavy water. Now, such reactors are sometimes called the swimming pool type because the whole process, the whole reactor is built inside water. Well, in a PWR, that is pressurized water reactor. This is a pressurized water reactor. The heat is removed from the reactor by water flowing in this pressurized chamber. This purple color is the pressurized water chamber that removes the heat and then transfers it into the secondary water circulating. The secondary water circulating system will absorb the heat, will generate steam, which is then used for producing electricity. So the heat is transferred to a second water loop through a heat exchanger. This is the heat exchanger. All right. Water boils in the heat exchanger, producing steam at very high pressure, which then turns the turbine, producing electricity. Well, in a BWR, BWR stands for boiling water reactor. Now, it's a much more simplified one. There is no heat exchanger. The coolant itself, or the moderator and coolant itself, will be the heat exchanger. In other words, the heat is generated directly there. Instead of using a heat exchanger, heat is generated directly inside the chamber itself. And that steam is then used for generating electricity. So that is a boiling water reactor. Now, what is a breeder reactor? Of course, breeder means